Now, we now know the basic of circular motion. There can be a type of circle. There can be two types of circular motion. For us, we will stick to two types. The first one is uniform circular motion, and the second one can be non-uniform circular motion. So we just say it as UCM and we say it as NCM just for the sake of simplicity. So we don't have to worry about non-uniform circular motion. We will not talk about it at all. But what is uniform circular motion? Now, when we say uniform circular motion, we know that when a body is performing circular motion, there will be a body performing circular motion at a circle with radius r. It will have some tangential velocity v. So in a uniform circular motion, the magnitude of this tangential velocity, and the angular velocity are constant. Just remember that the magnitude of tangential velocity and angular velocity is constant. Why I am specifying magnitude, why I'm giving so much stress on magnitude? Because from this position A, if this body reaches this position B, the velocity will be in this direction. Now magnitude will be same. Here magnitude of VA and VB, magnitude of VA will be equal to magnitude of VB. But is my vector VA equal to vector B? No. This vector has a direction in a different, this vector has a different direction, this vector has a different direction. So directions are different. That means the magnitude can be same, but the directions are not same. So in a simple sense, when my body moves from point A to point B, there is change in velocity. It's just directional change, but change is change. So change in velocity is happening. And if there is change in velocity happening, that means my motion is accelerated motion, because acceleration is rate of change of velocity. So there is some acceleration. It's a non-zero acceleration, and there is some acceleration. Now the question arises, what is this acceleration? Where is this acceleration? What is the direction of acceleration? All these things. So this, if you look here, the velocity, the direction of velocity is, if okay, let me add one more point, C. If you look, the direction is always being changed toward the center. From this, it is changing toward the center. That's why it's like this. From this point, it is changing toward the center. That's why it becomes like this. So this gives rises to something called as centripetal. So the acceleration we have here is called as centripetal acceleration. That means it is directed towards the center. So this acceleration is directed towards center. Now in your exam, you will always find, always in the sense, I have seen it twice or thrice, that there is a question which asks you to figure out, to derive, actually it's a 5 marker, you derive the equation for centripetal acceleration. Now in our textbook we have one way, we have done that way. I will not repeat that way. Let's go on to a part where we are doing it in a different way. So to do it in a different way, we first consider a body performing uniform circular motion. And when the body is performing uniform circular motion, it is at point A, and in some small time t, it will go to point B. Here, when the body is moving from point A to point B, I want to figure out how much is the acceleration. That means if I know what is the change in velocity, I'll know what is acceleration. So what I do is that I'll take this vector VA vector VB and I'll put it across like this. Now to find the resultant, obviously the problem is to find the resultant. We have always learned that the resultant vector starts from the tail of first and goes to the head of another one. So here what I'll do is that I'll rearrange it in opposite direction. So this becomes minus VA and we come across this thing. So tail of first to the head of another. This is my resultant vector. That is nothing but change in displacement, because resultant vector is sum of these two vectors, and when you sum these two vectors, this will be nothing but VB plus minus VA. So this is nothing but your change in velocity. So if I know change in velocity, I can easily figure out what is the acceleration in a given time. To do that, let's try to figure out what is the value of this change in velocity. Now, physics is all over. Now we are doing complete maths. We have to use a concept which we have learned in our IGCSE mathematics, something called as law of cosine. Now here in this case, in this triangle, if you see, we have three sides, we have one angle, so we can apply law of cosine here. And when we apply law of cosine, I'll come to a position, an equation which says that dV is equal to VA squared. Now if I square negative VA, it will be minus minus positive only, plus VB square minus 2 times VA negative, I'll put negative, VB cos of d theta. This is what we get, dV square, sorry. So dV square is equal to VA square plus VB square minus 2 times negative VA VB cos d theta. Now the good thing that I know about here is that this negative VA that we are using is just to represent the sign, that it is going in opposite direction. It has nothing to do with the magnitude. That means I know that the magnitude VA and VB is basically my same. So I will call them as V. So when I can use that equality that I have given right now to rearrange and rewrite this equation. I'll get dV square is equal to V square plus V square minus 2 times V times cos delta theta. That gives me dV square is equal to 2 times V square minus 2 times V square cos delta theta, and dV square will be, can I take 2V square common, and I'll be remaining with 1 minus cos d theta, and taking square root on both the side will give me dV is equal to V will be outside of the square root because it's V square, and that will give me 2 times 1 minus cos delta theta. This was algebra, all algebra here. Now this is an important thing that we have done in AS level, and I remember all of you have done this. If I take theta in radians, now remember theta is always in radians here. If I take theta in radians for let me remove this thing. For my theta, which is very small, very small, I know that sine theta is almost equal to theta, tan theta is almost equal to theta, and then when we come to cos theta is almost equal to 1 minus theta square upon 2. That means instead of cos theta, if my theta is very small, I can write down this thing. Now you can use your calculator, you can prove this thing, but I'll be sticking to just substituting this value. So if I substitute it here, I'll get delta V is equal to V times 2 times 1 minus, instead of cos delta theta, I'll have 1 minus delta theta square by 2. That is 1 minus delta theta square upon 2. Now if I open the bracket and I go on solving this, I'll get v is equal to under root 2 times 1 minus, this will become negative, negative negative becomes positive, delta theta square upon 2, and minus 1 plus 1 goes away, and we are left with v is equal to, okay, I'll just solve that part. 2 times delta theta square, this is delta, upon 2, and this is under root delta theta square, so I get v times delta theta square delta v. So I figured out, oh, this should not be delta theta square. Square and square root gets cancelled out. I figured out that delta v, that is change in velocity, is nothing but v times delta theta. And if you know what is velocity, we have a very basic formula that acceleration is rate of change of velocity. And we substitute this equation here, and we are left with acceleration is v times delta theta upon delta t. And in the previous video we have learned that omega is equal to delta theta by delta t. So I can substitute omega there. So I'll just make a bracket, I'll make it here. That means my acceleration is v times omega. Apart from that, we also know that v is equal to r omega. That means omega is equal to v over r. So if I substitute it here, I'm left with a is equal to v times v by r. That means a is equal to v square by r. This is the magnitude of centripetal acceleration. This is how you are supposed to solve in your exam. So I'll take you again. In your exam, you have 2 points where you say that one velocity VA, one velocity VB, radius of the circle is r. They inscribe a small angle delta theta at the center from going from point A to point B in a small time delta t. You should mention that the time taken to go from point A to point B is delta t. So now using vector, what I do is that I put A and B in a triangle form. Then obviously I cannot find the result. I can find the resultant obviously, but what I do is that for simplicity I just reverse it, so it becomes minus VA. Now it's from tail to head, and this is nothing but change in velocity. Why it is change in velocity? Because resultant vector is sum of vectors, and this becomes negative V. So VB plus minus VA is nothing but VB minus VA. That is nothing but change in velocity. Any final minus initial. So now with the help of vectors, I figured out I figured out delta V is your change in velocity. Now to figure out delta V, I use algebra. I use law of cosine. Now let me write that again, because you will find this PDF attached to the video at the bottom. So you can always take the notes from the PDF. So what I do is that then I use the law of cosine in this triangle and I solve it. Delta V square is equal to VA square plus VB square minus 2 times negative VA VB cos theta. Now here what I use is that I use VA is equal to VB is equal to V, because we are trying to find out the magnitude, not the direction. We are dealing with only magnitude. When we talk about magnitude, it's a uniform circular motion, so magnitude is same. So I can just call VA VB as V. When I substitute this, I solve it, I reach this point. At this point, I'm using this approximation. I'll just make this. So I'm using this approximation. In this approximation, I said that if theta is very small, your cos theta can be written as 1 minus theta square by 2. That means if I substitute this for cos delta theta, I'll get 1 minus delta theta square by 2. Then I open the bracket, I solve, I do algebra, a lot of algebra. I figured out this is my expression for change in velocity. This is my change in velocity. But acceleration is rate of change of velocity. Rate of change means with respect to time. So acceleration is rate of change of velocity. Then what I do, I substitute my this thing and I'll reach this equation. A is equal to V delta theta by delta t. Now we know that delta theta by delta t, or d theta by dt, is nothing but omega. I substitute it, I reach this equation. A is equal to V omega. Now we know that V is equal to R omega, so omega is equal to V by R. I substitute that A is equal to V omega. I reach this equation where it says omega is V by R, and V times V is V square by R. Now if I want to represent direction, I'll just say according to the direction it is always directed toward the center, so it is A is equal to minus V square by R. This is your expression for centripetal acceleration. Now in your exam, do you need to do all these things? No, I'll just make a mark of it what is to be done in exam. This is to be done in exam. This is to be done in exam. This should be somewhere, these things should be shown in exam, that you are using law of cosine. This thing should be shown in exam. This thing should be shown in exam. These two things will obviously to be shown, and then your final explanation. Now you don't need to solve all these things in between. These things, if you can if you can directly solve this thing and this thing, no problem. But we know that we have a lot of time constraints, so we don't know what to be done in exam. But yes, these are the few things that will grant you the marks that is required, and I have marked it. You can use the marking, make your own note, practice it enough so that you are very familiar with this way of solving, because in your mark scheme, Edexcel is expecting you to solve it in this way using algebra, not the trigonometry that we solved using the textbook. So that's all about centripetal acceleration. Thank you.